Hi, welcome to the notes for H3-12 on solving rational equations. The past couple lessons we've worked on simplifying rational expressions, right? There was no equal sign, we were just trying to simplify the expressions. Today we're going to actually figure out what the values of the variables are going to equal. So our two objectives, basically to solve rational equations, and the second one would be to make sure we're checking our answers for extraneous solutions. Now, we did do some of this in chapter 1, so it should look familiar to you. We just didn't do as many algebraic fractions. Let's get started. So the first one should look familiar. This is the kind of problem we did back in chapter 1. We want to solve this equation that contains these rational expressions, but we want to get rid of the fractions when we're doing it. So the way we did this earlier in the year, remember, is we found out what the least common denominator would be. In this case, what number do 6, 4, and 3 all go into? That would be 12, right? So if we wanted to get rid of our fractions, we could multiply everything times the 12, because 12 is divisible by 6, it's divisible by 4, and it's divisible by 3. So let's go ahead and do that. And do we have to do just 12? No, you could do a number, a number that's larger, but then it just requires maybe a little bit more work down the line. But any number that is divisible by 12, 6, by 6, 4, and 3 will work. All right, so when we do this, we're going to have a 12x squared over 6 plus a 12 times the quantity of x minus 2 over 4 is going to equal 12 times the quantity of x plus 1 over 3. And this is going to allow us to, divide by our denominator and cancel them out, right? So 6 goes into 6 once, goes into 12 twice. Then 12 is divisible by 4 3 times, and 12 is divisible by 3 4 times. So what we're looking at now is 2x squared plus 3 times the quantity of x minus 2 is going to equal 4 times the quantity of x plus 1. Now you'll just simplify each side of the equation and then look to solve it. So make sure you distribute your terms all the way through. And now it looks like we're going to have a quadratic equation, so set it equal to 0. And please be careful. I see a lot of people who don't write this step in there, and then they make mistakes when they're moving things from one side to the other. Seems like such a little thing, but if you're one of those people that makes a lot of mistakes, you need to make sure that you're being careful. So 2x squared minus x minus 10 should factor. I think we'll have, what, a 2x and an x. And let's see, 2 times 2 is 4, and 5, so that'd be a difference of 1. So we need to have a 2 here, a 5 here. This would be a minus, this would be a plus. And, if you need to take your time and factor it on the side when you're working it out, that's just fine. But for notes, you understand that you're factoring it, and this is what it is when you factor it. Set each of our factors equal to 0, use our zero product property. So x is going to equal 5 halves, and x is going to equal negative 2. Then we just need to take it and plug those back in to make sure they work. Okay, so that can be done on the calculator or it can be done on a sheet of paper. For the time's sake of the notes, for this problem, I'm going to tell you that those both work. Those answers are correct. Okay, so I'm going to move on here so you don't have to watch me check problems. Okay, so let's look at the next one. So this one's a little different in that our variables are now in the denominator. And one of the things that we're going to have to look for as we get started here is the excluded values. Remember, excluded values are values that make our denominators equal 0. So again, they are values that will make the denominator equal 0. We don't want those because then we have something that's undefined. Denominator, right, equals 0. So we want to find out what those are. And sometimes you can do it before, you can do it after. But all I'm going to do, remember, is we're going to set each denominator equal to 0 and solve it. So that first one we set it equal to 0, it factors into x plus 2 and x minus 2. So when we solve those, we get x equals negative 2 and x equals positive 2. And the second one there, right, was just x plus 2. So that one is also going to be x equals negative 2. So here's the thing with these, right? We're going to say here that x cannot equal our negative 2 and our positive 2. Those are the only values that show up as excluded values. So x cannot equal negative 2 or positive 2. So when we solve this, if x ends up equaling one of those two values, we have to throw that answer out. So let's look at solving this one now. We have 10 over x squared minus 4 equals 1 minus 1 over the quantity of x plus 2. Okay, so we're going to do it just like we have been doing in the recent lessons here. We want to make sure all of our denominators are factored first. So we're going to have a 10 over the x plus 2 times the x minus 2. And that should equal 1. And you know what, I'm even going to throw it over 1 for just a moment. Minus our 1 over x plus 2. So that value that we want to multiply by would have to have a factor of x plus 2 in it. It would have to have a factor of an x minus 2 in it. And then everything has a factor of 1, basically, so we don't have to worry about the 1 as much. So our least common denominator that we want to multiply by has to contain that factor of x plus 2, and it has to contain the factor of x minus 2. So all of these denominators could go into that expression. So we'll multiply each side here. I've got my x plus 2 times my quantity of x minus 2, my x plus 2 times my quantity of x minus 2. So when I do that on the left side, right, I don't even have to write it all out, because I know here that when I do that, I'll have 10 times the quantity of x plus 2 times x minus 2, and then it's going to be divided by an x plus 2 and x minus 2. So this is getting rid of those denominators. So our left side is just 10. Now, when we take it on the right side, right, we've got two terms here because of this minus sign. You have to multiply it times the 1 right here, and then you have to multiply it times this one. So when we do the first one, there's nothing to cancel out on the bottom, so we're going to have an x plus 2 times the quantity of x minus 2. And then we're going to have minus. And on this side, when we do it, right, our x plus 2 will cancel out with this x plus 2. So we're just going to have minus the quantity of x minus 2. Make sure you put the parentheses around it. That's important. And now we're just on to that same thing as in the last example, where we need to simplify both sides and solve it. So make sure you FOIL this. This would be x squared minus 4. And then we're going to distribute this negative through. So minus x plus 2. So when I combine my like terms, I've got x squared minus x minus 2 equals 10, and then we'll subtract that from each side. And now we've got not 10, we've got 0, right? 10 minus 10 equals 0. And that would be x squared minus x minus 12. And when we factor that, that should be an x minus 4 and an x plus 3. Set each of those equal to 0. And we know that x equals 4 and x equals negative 3. So the first thing that comes to mind here, right, is when we're checking these, right, we want to make sure that it doesn't end up being any of our excluded values. And in this case, it doesn't. And then we can just take them and you can check them by plugging them in on the calculator or taking them and, doing it on paper. It's up to you. Sometimes it's pretty easy to do. Like if I wanted to check one of these ones here, let's do, how about our 4? Right, you could do this real quick on the side. Let's say we're gonna check our 4. We're doing 10 over 4 squared minus 4. Well, 4 squared is 16. 16 minus 4 is 12. So we've got 10 over 12 should equal 1 minus, and when I plug in 4 there, I'm going to have 1 over 4 plus 2 would be 1 over 6. Okay, so 1 minus 6, right? Well, this is 6/6 minus 6 would be 5/6. And 10 over 12 reduces to 5/6, so I know that that is correct. Okay, and you can do the same thing with your negative 3. Take it there, plug it in, make sure it works. So chances are it's probably going to work here with this one. We could say 10 over 9 minus 4 would be 5. And we have 1 minus, and then we have 1 over negative 3 plus 2 would be negative 1. So it's like 1 minus negative 1 would be 2, and 10 divided by 5 is 2. So look at that. It took a whole 30 seconds there for us to check both answers, but now we know they're both correct. Let's move on. Example 3, same kind of deal here, right? We're going to be looking at our factored form of our denominators to multiply by what a value that would be divisible by each of them. So when we do this one here, okay, we notice that I'm going to start on the right side, which is kind of strange, I know, but let's just do that, right? 1 minus 5x, right? We know that's over x plus 3. That's not changing. In the middle, we have x squared minus 9, which we know is an x plus 3 and an x minus 3. Okay, so as we look at it so far, right, they both have an x plus 3 in them, and then this one also has an x minus 3. And I'll still bring down my denominator. I'm sorry, my numerator. And then over here, though, we see we have a 3 minus x, right, which is different. It's the opposite of our, x minus 3 that we have right here. So what we want to do here, let's make it the same. Let's factor out a negative 1. Okay, so let's take this and rewrite this as negative 1 times the quantity of like negative 3 plus x, right? When I take out the negative 1, it flips the signs. And we can also take it and then rewrite it as negative 1 times x minus 3. Now this actually truly matches, wrong tool, this truly matches what we have down here, right? But then what do we do with that negative? Okay, well, let's take this negative 1, right? And let's move it up to the numerator. We'll take it and we'd say, hey, we're going to turn this into negative 1 times the quantity of x plus 3. So what we see here is negative 1 times the quantity of x plus 3 now over our x minus 3. And what's that do for us? Well, when we're trying to figure out what our least common denominator is, now we've cut down on a factor that we have to multiply by, or we'll be less confused by that opposite term that's in there. So we need to make sure that our number that we're multiplying each side by has a factor of x plus 3 and a factor of x minus 3, because they each have at least one of those. So let's multiply everything times our x plus 3 times the quantity of x minus 3. All right, so as we do this here, right, we're going to have x plus 3 times x minus 3. We know that our x minus 3s are going to end up canceling on this one, so we're going to have that negative 1 times the quantity of x plus 3 times another x plus 3. Okay, so that's this one, and that one. Then we have plus, and on the middle term, right, they're both going to cancel down here. So that's nice. So we have 11x plus 3. And that would equal on this side, we still are going to have our 1 minus 5x, and then our x plus 3 factors will cancel, so we still have that x minus 3. And now that simplifying part comes into play, just make sure you're careful as you FOIL everything out. On the left side, right, I'm going to multiply these two terms together before I deal with that negative 1, because this is just going to be a perfect square trinomial, and that's really easy for us to multiply. Right? Now I'll take that negative 1 and distribute it through. Okay, so don't distribute it through first. I mean, you can, but I just think it's easier not to. We have negative x squared minus 6x minus 9 plus an 11x plus 3 is equal to, and then we need to FOIL this out. So we have 1 times x is x, 1 times negative 3 is negative 3, negative 5x would be a negative 5x times x would be a negative 5x squared, and then we'd have plus 15x. So when we simplify that part of it, negative 5x squared plus 16x minus 3. On the left side, when we simplify that one, we should have a negative x squared plus 5x minus 6. So we're to the point now where we want to take this and solve it, so we need to set it equal to 0. All right, so it's just quadratics. We've done this all before. I want my x squareds to be positive, so I'm going to move my right side to the left. I realize this is the challenge for some of us here, is when we get quadratics that have a's in front of them. Okay, so just take your time, do it there. If you need to factor it here, it does factor. If you want to take your moment there, pause the video and factor it on the side, go for it. Okay, what you should end up with here is a 4x in the front of one and x in front of the other. We're going to multiply 3 times 4 to get 12, and then we have a difference of 12 and 1 gives us our 11. So this needs to be negative, this needs to be positive. And then we'll take each of those and we will set them equal to 0. And we'll get x equals negative 1/4 and x is equal to 3. Now, the part that I didn't do at the beginning, that I did at the beginning of the last problem, was I looked for my excluded values. Okay, so excluded values are important. Remember, we take our denominators, right? And I'm going to do this over on the side over here. My excluded values are going to be, if I take 3 minus x and I set it equal to 0 and I solve it, I get x equals 3. So right off the bat, that tells me right here that since x, let me write this in there, x cannot equal 3, right? That's going to eliminate a solution down here, right? X cannot equal 3. That's not going to work, okay? Because if I plug 3 in there, I'm going to get 0 for my denominator. Now, for the other ones there, you'll notice there we have the difference of squares and the x plus 3, right? Let's just focus on the difference of squares for a second. That factored into x plus 3 times x minus 3. So we knew that x could not equal negative 3 and x could not equal positive 3, right? So and the last one, the x plus 3, would also repeat that x minus 3. So we're going to say for our excluded values, x could not equal negative 3 and 3. And since that one solution was a 3, we have to throw it out, and negative 1/4 would be our only answer. And if you go back and check that, negative 1/4 does work, okay? But for time's sake, I don't want to, overdo it on you here. So negative 1/4 does work. You could plug it on your calculator. That one could be a little complicated trying to do it by hand. Okay, so our answer, x equals negative 1/4. Let's move on. So let's go ahead and do our excluded values on this one right away. All right, our excluded values here for this one, y minus 1 equals 0. We solve it. That means y is equal to 1, so we can't have y equal 1. And then our y plus 1 equals 0. We solve that. We get y cannot equal negative 1. So y cannot equal 1 or negative 1 when we're finished solving this. Now, when you see this one, I like to make this one a little bit easier because we have 5 over y minus 1 minus a 4 over y plus 1 equals 0. Okay, so I have a fraction minus a fraction equals 0. I like to take this and move one of my fractions to the other side to create a proportion. So now what I have here is 5 over y minus 1 equals 4 over y plus 1. Okay, so you can still take it and multiply by that value that contains the factors of each of the denominators, right? If you wanted to, you could say my least common denominator would be y minus 1 times y plus 1. You can multiply both sides, which is still going to be just the same thing as cross multiplying here because it's a proportion. Okay, it will get you the exact same answer in the next step. So you should have a 4 times the quantity of y minus 1 equals 5 times the quantity of y plus 1. And now let's just simplify each side and then solve it. So we'll subtract our 4y, subtract our 5, and we have here that negative 9 is equal to y. Okay, so good thing for us here, right, is it does not it does not fall into our excluded values category. And then, so if y equals negative 9, we should be able to plug it in and check it. All right, let's just do 5 over negative 9 minus 1 minus 4 over negative 9 plus 1. That should equal 0. So this is 5 over negative 10, which is negative 1/2. This side we have minus 4 over, what is that, negative 8, which is a negative 1/2 as well. And negative 1/2 minus a negative 1/2 would give us 0. 0 equals 0. Okay, so we know we're right. Y equals negative 9. All right, so we just got a couple more here. I don't want this to get too long, so I'm trying my best to get through it as quickly as possible. This one's the same thing here, so we'll shoot through it real quick. When you take it and you factor it first, okay, the left side doesn't factor at all, and then the right side would factor into an x let's see, minus 2 and an x plus 1. So it has the same factors as each of the fractions on the left. So when you take it and you multiply it, you're going to multiply it by an x minus 2 times an x plus 1. Now, if you want to go ahead and make sure you pause the video here and go through it, just make sure that at the end, before you come up with your final answer, you check for your excluded values. In this case, x cannot equal -1, and x cannot equal +2. So let's just go ahead here. I'm going to shoot through it quickly. So I'm going to multiply by x minus 2, x plus 1. So when we do this here, I'm going to have a 3 times the quantity of x minus 2, right, because our x plus 1's canceled. And then in the second term there, our x minus 2's are going to cancel, and we're going to have minus the quantity of x plus 1. And then the second one there, both are going to cancel, leaving us with just 1. And then just go ahead and simplify 3x minus 6 minus an x minus a 1 equals 1. This would be 2x minus 7 equals 1. We add our 7 to get 8. 2x is equal to 8. We divide each side by 2. We get x equals 4. Okay, so it checks out with our excluded values. 4 should work there. And when you take it and you plug it in, it will end up working. So please make sure you do take the time to check your answers, even though I'm not doing it for every one of them at the moment. But like I said, you know how to do that, and I don't want to drag on this video any longer than it has to be. All right, so into the last one here. Okay, so this one is a little bit trickier. It says the quantity of x minus 3 over x plus 1 all squared equals 2 times the quantity of x minus 3 over x plus 1 and then plus 3. So I'm going to talk to you real quick about 2 different ways you can solve this. So first of all, when you look at it here, we know that our excluded value, we can actually just see what it's going to be in this one because we only have one algebraic expression in the denominator, right? We're going to say that x cannot equal -1. Now, when you think about this left side here, don't make it more complicated than it needs to be. Think about it as x minus 3 times the quantity of x minus 3 over an x plus 1 times an x plus 1. Right, that's going to equal 2 times the quantity of x minus 3 over an x plus 1. Right, it just looks a little bit more complicated because of the way they wrote the grouping symbols. Plus a 3 over 1. So when you're looking for what value would you multiply everything by, okay, in this case, right, when we look at this, let's look at that first fraction. It's got a factor of x plus 1, so this has to have a factor of x plus 1 in it. But notice it also has a second factor of x plus 1. So since it has 2, we are going to have to include x plus 1 twice. Okay, because x plus 1 times x plus 1 is going to be divisible by itself twice. And then this is also divisible by this and this. So that's what you want to multiply by. You're going to take it here and you're going to multiply both sides by an x plus 1 times an x plus 1. We'll do the same thing on the right side. So notice everything will cancel in our denominator on the left side. So we've got an x minus 3 quantity squared, or x minus 3 times x minus 3. And on the right side, right, one of them would cancel with our fraction on the left, leaving us with 2 times the quantity of x minus 3 times the quantity of x plus 1. And if you set up your paper neatly and stuff there, it makes it still pretty easy to do. Okay, even though it looks like it's going to be long and complicated, it's not that bad. And then we're going to do a 3 times the quantity of x plus 1 times our quantity of x plus 1. Right, nothing cancels in that last fraction. So it's just a lot of foiling in this problem. You've got an x squared minus 6x plus 9 is equal to, and remember, I would do the binomials first here. We're going to say x squared minus 2x minus 3, and then you're going to distribute your 2 through to get 2x squared minus 4x minus 6. And then on this one, I'm going to bring down my plus 3 because I'm going to multiply it by the x squared plus 2x plus 1. And this is why we practice all this at the beginning of the year, so you should be able to do what I'm doing right now. I know you're not all there yet, but the more you work on it, the easier it gets to be able to multiply these things without having to draw it all out and draw the box and the diamond and all that fun stuff when you're doing those kinds of things. Okay, so let's combine the like terms on the right side. We've got a 5x squared. We've got plus 2x minus 3 is equal to x squared minus 6x plus 9. And now it's quadratic, so set it equal to 0, subtract one side. I would do the left side because that way we're going to have a positive x squared. So we're looking at 0 is equal to 4x squared plus 8x minus 12. And does it factor? Sure does. Let's pull out the greatest common factor of 4 first. And that makes it really easy to factor the rest of it. So we have 0 is equal to 4 times the quantity of x plus 3 times x minus 1. And when we set each of those equal to 0, remember, you don't need to set 4 equal to 0. We're going to get x equals negative 3 and x equals positive 1. Neither of those is the excluded value, so it looks like it's going to be pretty good for us. We can take it and plug in those values to check it. I'm going to let you do that. So that's a little bit longer approach. I am going to show you a second method if you're interested. If not, go ahead and shut off the notes. If you want to see another method, maybe a little bit more advanced method there, but it's actually easier to do, then stick around here and maybe find a little bit of extra room on your paper. I'm going to jump across here. You see I have that same problem written down. Now something we notice here on this one is that we've got this expression, x minus 3 over x plus 1, is in there twice, right? And that's actually our fraction. One of them is being squared and one of them is not. So this kind of goes back to our notes from H3-9 that you did not get to do because we had to exclude that because of the time crunch with the COVID. So let's do this. Let's put something in to replace our x minus 3 over x plus 1. Let's call it u. Okay, let's call that u. So if you think about it, instead of squaring all of this, right, let's just treat it like I'm squaring u. So this is u squared is equal to 2. And then we have that same expression, so times u plus 3. Now this one looks pretty easy to solve, right? If we take this now and we set it equal to 0, it factors into u minus 3 and u plus 1 equals 0. We solve each of those. We get u is equal to 3 and u is equal to negative 1. Right? Did I do that right? Did I factor that correctly? Yes. Okay. So now, I know we had said before that we had our excluded value, right, was that x cannot equal negative 1. But we're not talking about x right now. We're talking about u, and it's a different letter, right? So don't throw this one out because the u equals negative 1. Here's what we need to do at this point, right? So we're trying to solve for x. So what we're going to do, we know that u is equal to that, right? We've got these u's. Well, u really equals x minus 3 over x plus 1. So we're going to substitute that back in for our u's. Okay, so I'll do that over here on the right just so I don't run out of room. Right, so for my u minus 3, it's really the same thing as x minus 3 over x plus 1 is equal to 3. And for the other one, we'd have an x minus 3 over x plus 1 is equal to negative 1. I'm going to treat those like they're proportions and just cross multiply and solve. So 3 times the quantity of x plus 1 should equal x minus 3. We'll distribute that through. 3x plus 3 is equal to x minus 3. So we're going to get a 2x is equal to negative 6. So we get x equals negative 3. If you look over here, I think we already had that, right? So this is a good way to check our answer too, just solve it using a different method. We'll cross multiply here. We're going to have a negative 1 times the quantity of x plus 1 should equal an x minus 3. So when I add my x's, I got a 2x there, and I add, if I add my 3 over to the other side, I will have a 2 over here, so I get 2x equals 2, and then I divide each side by 2, and we get 1 equals x as well, which notice is the other answer we had. So this is just another method for solving it. I know some of you guys are really good at math, and I want you to see some of the advanced techniques. So this is an opportunity to use something like that, okay, if you want to try it. Okay, but that only works when you've got something that's in this quadratic form, where you've got that expression being squared, right, times just that expression to the first power. And when you see that there, it could be rewritten as a quadratic. All right, if you have questions, please let me know. Otherwise, thanks for watching.